All right. I'm in a really interesting position today. I'm standing in between you guys and happy hour. And I noticed that this talk was scheduled to end at 5 o'clock and happy hour starting at 5, which means if you wanted some time to go freshen up, you wouldn't have that. So if you guys don't mind, I'll try to squeeze this talk down into maybe half or 60% of the time, if you don't mind. At least get you to happy hour. So the title of my talk comes from a movie, and these graphics are not mine, the Somm and the wine bottle. It's all from the movie called Somm. If you guys, do we have any wine drinkers here? Yeah. So there's a really cool movie on Netflix called Somm, and it's about people who are testing to get certain levels of, to make certain levels of the sommelier. And it's a very interesting movie if you see it, but I kind of based it on, some of the concepts around aging well, which is something that they sort of learn in that movie. So I'm an enterprise architect at Lightbend, and Lightbend, in case you didn't know, it was formerly known as TypeSafe, the corporate stewards / inventors of Scala, Lagom, Play Framework, Akka Framework, heavy contributors to Spark, and all of our stack runs with both Scala and Java APIs. So we've taken a lot of care to make sure that everything that runs with the Scala API has parity with the Java API. Headquartered in San Francisco and also in Lausanne, Switzerland. Some other interesting things, our CTO was a spearheader of the Reactive Manifesto. If you've ever heard of the Reactive Manifesto or reactive programming, Reactive Systems, we're sort of the team that birthed that. So about me, some things I like. I really like aerial views, looking at the ground falling down to it. I like mountains. I like traveling to lots of different cities. And if you like travel, I have Instagram at That's Kiki with some interesting pictures. But interesting enough, I don't like heights. But the only way to see those really great aerial views is to jump out of airplanes or hang glide. So something I have to conquer. I don't like wild wildlife, which is wilder than regular wildlife. I don't like unintentional sharing, which we can talk about at happy hour. And I don't like weird taboola ads. Do you guys see those things? I just hate those weird ads. But enough about me. I'm pretty sure you guys have been through the conference, we're about a day in, and someone's gonna tell you that there's some huge shift coming. There's some brand new paradigm that you need to be aware of. But is there really? Right? You'll hear, we're in the IoT economy, we're in the API economy, this is the time of the gig economy. Some economy is coming up, right? Before the end of it, I'm sure we will have lived through plenty of them. And we may not guess the next big economy, but we can be sure that something is coming, right? And that's because change happens fast. There's a constant stream of innovation and innovative ideas that need to be turned into tangible assets. New economies arise, and they're largely driven by technology and tech companies. But in all this change, one thing remains the same, and that is the importance of your systems. Systems themselves are what really bring these economies or these eras or whatever you'd like to call them to life. If you think about the logistics of delivering fresh food to me in the city within 2 hours of ordering from my phone app, you're like, man, that's an amazing thing to do. But think about it again from, my fridge ordered it for me, I had nothing to do with it, also made sure that it was delivered, and all I did was get a notification on my watch or something like that. All of these things are here now and coming, and the basis of them are software systems. And that's all great, but there's another consequence to rapid change. and that is rapid aging. And if you guys are listening to the keynote this morning, one thing that was mentioned is that, you know, a lot of stuff that we see today, even now, will be obsolete sometimes 6 months from now, sometimes a year from now. You really can't guess how long something's going to live. You can know that it's going to change. But right now, with the rate of things moving, with an example being the JavaScript world, change happens really fast. And you'll notice something interesting about our tools and how they've changed with this different rate of change that you see in the world. Our tools have evolved a lot. Throughout history, we've had lots of things to help us build software, and you'll see one interesting pattern that has to do with levels of abstraction over time. So if you look at the rate of change, you know, things used to move really slowly. And at that point, you know, we had low-level languages that were being used. And low-level languages, they worked for what they needed to do. But at some point, we thought we needed higher-level languages so that I don't have to encode machine language in a way that's really not human readable. So there are a lot of things that high-level languages did for us. They made things a little more readable. They made sure that whenever I want to use such a primitive type, it was always encoded the same way. I mean, there are things that these languages and these higher-level abstractions do for us. And we had the advent of libraries and packages. And then finally, as we needed to start building applications faster, and by faster I mean within 1 year or 2 years, we had application frameworks. And frameworks help us encode some interesting patterns, like MVC, when that was a thing, right? But something has changed. And we're starting to move a lot faster than application frameworks can help us to move. And what is that? We are in a very rapid system building era. It's not to say that we weren't building systems before, but before, systems weren't changing so quickly that they aged and degraded in a really poor way. It was common before that you could have a system that, I mean, I've worked in companies where we had a system planned to take, 3 years to build, and it's going to stay around for the next 15 years in maintenance mode. And that was a real thing a long time ago. And now there's the other extreme, where I know companies that deliver to production every day, multiple times a day. But not a lot of companies have that sort of discipline, so don't worry. And another thing that has happened, we've made a shift away from the monolith, large applications. And before you had a monolith, and monolith is a bad word, but it kept everything contained. And you had a lot of moving parts inside of that monolith, but they were contained. And now we don't have that. We're breaking that thing apart. And there are some side effects to that. So now that we're at that level of really fast systems, we need a new level of abstraction. You'll notice I've added application networking here, because that's something that's come about more recently if you're familiar with MuleSoft and what they're trying to do with application networks. But we need something with a much higher level of abstraction that will help you to build systems quickly. And I believe this is a newer territory, and I believe that this is sort of the next wave of a framework that will be coming out. And I'm going to talk about one that exists now for built in the JVM world, but I can really see this coming and showing up in a lot of other language systems. So I'm going to talk about Lagom. And this is an open source framework designed for building microservice systems. And when I talk about microservices, I don't mean small services in the sense of the size of the code, even though that is certainly an indicator. But when we say micro, we really mean a micro-sized intention. Is the intent of this system small Does it do one thing and do one thing really well? So Lagom, it is that next level abstraction. It is an abstraction over Play Framework, Akka, which is a web application framework, concurrency toolkit, and then some other curated tools. And another interesting thing is it encodes certain architectural principles and patterns that are used for building microservice systems. Now, I'm going to talk today about some of the challenges that we see in the enterprise when I'm implementing some systems and how Lagom itself reaches those challenges. So number one, in order to protect against aging, in order to recoup your costs fast, right, you need to be able to build faster. But you can't just build fast. You need to also maintain architectural integrity as you move fast. And that's something that's not always easy to do. So what's one of those challenges that we see? Well, as you know, we're here, we've seen probably already today 10 or 20 languages that we may use, may not use, may have heard of. There are too many choices and so many ways to build our systems that you end up in this sort of analysis paralysis. I work in enterprises sometimes where there's a whole list of, we have this is our governance board, and this is the list of approved technologies, and this is what you need to do to get through on the approved technologies. And they'll want to do benchmarking for every language or every framework and this theoretical system with this, and this, and you go through all that, and then you have people who are resistant to change because of all of that, and resistant for a good reason, right? We have React and Node and Gopher and Vertex and Hollow, and how do we use this all? It's too much, right? But Lagom makes some of those reasonable choices for you. If you're building a system, if you're building a microservice system, it makes some choices within the JVM world and also outside of that allows you to pull in these patterns to build the system. Out of the box, it makes enough choices that you will have a reactive system. Reactive being highly responsive, elastic, fault-tolerant, message-driven. Here are some of the components of Lagom. I've not listed everything here, but I've listed some of the major things that you would see in a microservice system. You'll see that we handle persistence in the sense of event sourcing. There's also CRUD, cluster, asynchronous systems, web framework, everything that you need without having to use that stuff directly. You don't need to be an expert in Akka or Akka clustering or Akka HTTP in order to benefit from the speed and resilience and fault tolerance of building an Akka system. Another challenge that I see is the difficulty to scale these patterns across your enterprise. It's hard enough to get one team doing a pattern right, You've picked out all your tools, you've picked out everything you need. Say you're using a different language, maybe not JVM, but you're going to cobble together the best of this and that and the other. Well, you've got your tools. How do you ensure that everybody on the team is using them in the right way? And I don't mean that everyone's doing the same thing, but at least when it comes to your architectural integrity and the patterns that work, you need to make sure that people are using them all consistently and that consistency scales. This is not something easy to do at that application, framework, or toolkit level of abstraction. What Lagom does is it allows you to consistently apply those patterns, right? Like I said, while most companies will depend heavily on written governance, review boards, documentation, user guides, just to ensure that consistency, and then it still doesn't happen, Lagom sort of encodes that into its semantic, into the API. Now that doesn't mean that I'm saying you need to throw away governance, but what I'm saying is we've built it with certain safeguards to ensure that you're able to be consistent across your groups. So what are some of those principles that are encoded into Lagom? One, single responsibility principle. You've got your service-oriented architecture, which is not the SOA of yesterday, But those principles within SOA still remain valid, so that we have better tools to implement them. Encapsulation within the service, and an important one, a hexagonal architecture, because we believe that these systems will be polyglot systems. Talk about that a little bit later. What are some of the design patterns that are also here? Some of those key patterns when you're building reactive microservice systems. One, asynchronous and non-blocking, right? Discovery, service locator, event sourcing, which is sort of a necessary evil when you have distributed systems. Domain-driven design, if you guys have heard of that. I mean, this is something that is encoded if you are using Lagom, if you are using the Lagom semantic and the API. These are the things that you get out of the box. For example, like I said, Lagom is both in Scala and Java, but I have a preference for Scala, just a personal preference, but you can use the same thing in Java. For example, if I wanted to describe, if I want to do event sourcing, right? Event sourcing is something that you could use a number of libraries to achieve, right? But then you'd have to keep up on all of those libraries and make sure that everybody knows how to use the library consistent. And then if a new library comes out, you may need to start doing benchmarks and all kinds of craziness. Or you could just use what's built into Lagom. I can easily define a topic. I can easily name that topic, right? Tell what events are going through that topic. And you notice here I haven't used any message broker API semantic directly yet. And that's just the API. And now in the implementation, it's very simple to stream those events. It's cut off here, but the important part is this, right? And now if I need to consume events from that topic from another service, again, it's really simple. I just subscribe to that event stream. And now, literally with just a few lines of code, you have event sourcing that can be used not only within your Lagom system, but in other systems that are subscribing to this. This uses Kafka behind the scenes. You may be able to use another distributed commit log in the future, but by publishing there, without anything that says Kafka, you don't see Kafka, create topic, anything like that, you've gotten yourself some event sourcing. That's just one example. So now, do you need experts? Someone's always saying, another challenge that I find in enterprise is, I can't adopt this technology because I don't have experts in this. They assume some army of experts. A lot of people say, we can't do Scala in our company because we need a lot of Scala developers, and Scala developers are hard to find. Well, it's not the case with Lagom. You don't need Lagom developers. I know sometimes say, oh, we need Spring developers or Akka developers or XYZ developer. That's not the case with Lagom. All you really need are Scala or Java developers or someone willing to learn Scala or Java and to apply the Lagom semantics. One big myth that I constantly have to tell people that's not true, expertise in a framework or a library or even a language doesn't really get you to the end of your goal unless that framework is designed specifically to your goal. So when it comes to Lagom, it's designed to build systems. So learning the semantic of Lagom will help you to build systems, right? But learning semantics of, for example, I know the Netflix OSS stack. But knowing a little bit about all of the pieces in that stack doesn't really guarantee that you're going to build a great system like Netflix has built. The next challenge is we must protect the developer productivity. Developer productivity is something that I always hear when I'm working with a company. Our developers need to be productive. Our developers need to move faster. They can't learn something new. But Lagom has built into it some really practical things for productivity. For one, again, in the JVM world, it allows you to use both Java and Scala API. You can use any IDE, Eclipse, you can use IntelliJ, which I tend to use. You can use just a notebook if you want to. It has batteries included. So one thing that I mentioned is that, you're building a system, you need to have certain things within it. For example, with persistence and event sourcing, you need to have a database that's good for event sourcing, and it comes out of the box with Cassandra. You don't install Cassandra, you don't need to describe Cassandra in a major way. It comes with this. It comes with Kafka in the background. And all of this stuff starts up automatically with your application when you hit run all. And if I have 5 minutes, I will show you at the end. But you can run everything out of the box that you need in order to build a system, test it, do some, quick sandbox testing without installing anything other than your Lagom jars, all the dependencies there. And it also has hot reload. And hot reload is really important if you develop and you remember the days of compiling and packaging and deploying out onto something and then realizing that there was something missing you forgot to add. I mean, that's ridiculously horrible to develop in. And with Lagom and with Play Framework as well, which is built on top of, you change the code, you refresh the browser, and it's there. It's a much more rapid feedback. And so one of the final challenges that you see is unplanned complexity or chaos. And this is one of the biggest challenges that I see in companies. Number one, like I said earlier, a monolith has many moving parts. And it always scares people to change anything inside of those moving parts. But at least with the monolith, it's sort of semi-contained. But a lot of companies think that they can just break the lid off of your monolith, drop everything off into their own microservices just like that, and then it'll work perfectly. And it just doesn't work that way. You cannot decompose your monolith by taking all those same components and just deploying them out into the world. It's not how microservices work. So what does Lagom do? It minimizes the chaos of decomposing your monolith by providing you isolation and very autonomous services. So each service, it basically can promise only its own behavior. It publishes its own protocol or API, and right now it's JSON over HTTP by default. In the future, you may see gRPC and Swagger, other things that are being built. And also, it has to be location transparent, and so they're all addressable. It encourages and enables you to contain mutable state and publish facts. So containing mutable state in all your services prevents data corruption. You can be eventually consistent with your data in a microservice system, which you always will be if your system is distributed, but you can't be corrupt, right? Your data can be inconsistent for a moment, but it cannot be corrupt. And in each system, each part has to take sole responsibility for their state in the persistence of that state. This means absolute data ownership is important. And with Lagom, I don't need to use the low-level semantics of Akka persistence in order to ensure that. Again, it's built in behind the scenes. So for example, if I have a persistent entity, I am encapsulating the state. State is changeable, but the state object is immutable. But I encapsulate that inside the persistent entity. And so I am containing the state here, but I'm publishing facts so that other people may react on the facts of that state, or I may be able to call up that state. And so I publish it. And again, it'll go to the event stream. Another thing Lagom does is it allows you to untangle your read and write models with CQRS and event sourcing. This allows for faster writes, efficient and elegant reads, all the benefits that you get using CQRS without being an expert or reading a book on CQRS. And there are some good books on it. Lagom uses asynchronous messaging in I/O by default and uses distributed persistent patterns. And this is pretty important when it comes to building distributed microservice systems. This is something that companies forget a lot. It's very easy to distribute an application that's stateless. Distributing stateless applications is pretty trivial these days. But distributing stateful entities is not a trivial thing. And it's something that Akka has addressed within its Akka persistence, and there are other libraries that semi-address this, but we've built it into the semantic of Lagom for you, so that you're able to distribute, a reactive system is made up of a couple of things, right? You can't have a reactive system with just reactive programming. Reactive programming is a part, but it's only a part. But to have a reactive system, you need to have a lot of patterns and a lot of other things in place in order for that system to have not only asynchronous and non-blocking semantics, but it also has to be resilient. It also has to be elastic. And part of that is being able to distribute those stateful entities, being able to publish your facts for your read model. This is all necessary and important in your system. And if I have time, we can go more in depth on some architectural photos here. And then finally, one of the biggest challenges that I see in the enterprise when people are trying to adopt new technology is they always think that it's all or nothing, or it's this and everything. By that I mean, people tend to believe that in order to move to microservices or move to MVC or move to whatever happened before that, you need to throw everything away and start over. But we can't throw everything away and start over, so we can't move to this, okay? And this makes people resistant to change for very good reasons. If they think that they need to destroy what exists before they can build something up, that's a really good reason to be resistant to change. So the other thing, when I said this and everything, that means that people sometimes say, okay, we've gone through this whole governance board review, we've done A, B, and C, and now as soon as we pick one of these things, this is going to be our standard for everything. From here on out, we're going to use Java for every single thing in the company. And that doesn't make sense, right? We live in a polyglot world. The whole point of microservices is that a service does one thing and does it well, which means that it may use a different language than Java or Scala or Go or whatever in order to do that one thing well. So the whole this and everything is a complete fallacy that you don't want. And to address that, Lagom it has that agnostic communication. So in case you do have parts of your system that are running in Go or parts that are running in something else, you can still communicate elegantly with those systems. So you don't have to fall into the all or nothing or this and everything trap when you're using Lagom. So I have one use case I'm going to skip for the sake of time. But this is just an example of if you were using a phased approach in order to decompose a monolith or your heritage system which may have had limited capacity, there are certain steps that you can take in building that out with Lagom. So what I'm trying to get across here is the fact that you have these patterns that exist for building your systems. And you have lots of tools that could help you to reach these patterns. But in order to use these tools, to pick the best of breed, there's a lot of stuff that needs to be in place. Like I said, governance, templates, ref apps, documentation, et cetera, et cetera, et cetera. And there's nothing really in place yet to help you to implement those patterns consistently until you look at Lagom. And Lagom uses these tools, right, as well as the others, to implement these patterns, But I can imagine that on the other side, you're going to see more people coming up with tools to bring these things together to allow you to abstract and build at the system level, particularly for microservices. So in summary, in order to age nicely, you need to be able to keep up with the rate of change. Systems need to be able to adapt quickly, right? And rather than using tools at a lower level of abstraction in order to move faster and to move very accurately, you want to have a next level framework abstraction. And this is where I see a shift happening. And what happens if you don't do this? Well, if you don't, one of the things I see is that people end up with the chaos that does ensue when you start trying to decompose a monolith by kicking things over and throwing things in there. And then you have that knee-jerk reaction of people pulling back and feeling more resistance to change. And you sort of want to avoid that. And at least one way to avoid that is to ensure that you're able to apply patterns consistently across your organization in order to at least limit the chaos that you may feel. Because sometimes that chaos comes from organizational changes or other things that aren't related to the technology. But you want to sort of be as frictionless as you can on the technology side in order to prevent that knee-jerk reaction of, oh, we're going back to our monolith. So, trying Lagom. Like I said, this is an open source tool. It's free. You can try it now. And we have some cool Hello World that you can use, but Hello World is not really cool. It's just to get you started. But we also have on our GitHub a full, robust application that you can use. It's called the Online Auction. And all of these are in both Scala and Java. So you can see an example of the Scala application or the Java application, and actually just compare the code, see how it works together. And that one is a really robust example that I would suggest looking at and using after your Hello World experience. And you can also read more on systems and what these microservice systems look like and some of the patterns more in depth, and how this book is really what Lagom was based off of. This is a book by Jonas Bonner, who's our CTO, Reactive Microservices Architecture. It's free. You can download it on our site on lightbend.com. And if you are kind of lazy and don't want to try it first, you can just ask me for a demo. I'm at Kiki at lightbend.com. Or you can chat me up on Twitter at Kiki's World Race. Any questions?
Hi, thanks for that talk. I was wondering, as far as use cases for Lagom, so what's the sort of largest size sort of organizations that this is sort of, shown that this pattern can sort of scale up to that size of organization?
Sure. Well, I've got a couple of use cases that started out pretty small, and then the organization saw that it worked, and so now they're scaling it across a larger organization. The first one was a pilot application with a financial company, I would say. And the team that started out building that was fairly small. I think there was a single pod of maybe, I'd say a total of 10 people. Now they're scaling this out across a number of pods. They haven't decided how many pods they're going to use, but it'll probably be 20, 30 pods of developers who are going to do this. And I've got a couple of other clients, maybe in telecom, that are looking to use this and also scale it across some really large teams. But first they have to have the experience and appreciation of using it within a small pod and see it proven out. And then people tend to scale after that. Yeah?
Actually, several questions, if you don't mind.
Yeah, please.
One is, one question is, if there is the ACA persistence query functionality in Lagom to query the event journal. The other question is if you're planning to provide out of the box read sites other than Cassandra, and which ones? And the third one is you mentioned that there is a DDD API. Could you please enlarge on that exactly? What besides the persistence entity exists there to, to apply the DDD more idiomatically?
Right. So the first question about ACA persistence, so getting the state,
query.
The query of the state. So what it does is each persistent entity actually, by default, it generates the state from the journal. It reads it as it loads up, and that's set as the state inside of your persistent entity. So when you do an ask, you don't have to do like an...
No, that wasn't the question. The question was not about ACA persistence. It was about ACA persistence query, which is the additional interface to query, for example, to obtain all the events that happened.
Yeah, that's what I'm saying.
Yeah.
So what it does is inside the persistent entity, it loads all of the events that have happened and it puts it in the state, and you query the state of the aggregate entity.
Okay. Well, that's fine. Next question, please. About the other read sites besides Cassandra.
Oh yeah. So you can use MySQL. You can use any. There are a couple of CRUD ones that are already in use that I think Postgres is also supported right now. But as far as NoSQL, the one that we have right now is Cassandra. But anything that has an ACA persistence journal, you can write your own. You can write your own persistence interface for that. So, for example, there's a journal that exists for Mongo. If you wanted to write your own, you could do that and switch it out.
Oh, there exists one for Mongo.
Yeah, there's a persistence journal for Mongo that already exists, and so you could write your own. Right.
Like with Reactive Mongo, okay.
And as far as DDD?
DDD, yes.
The thing that we have that helps you with DDD is basically within your aggregate entities. So in case you're designing and you want to do a bounded context, the API project and your implementation projects are representative of your bounded context. Your aggregate entities are representative of an entity that we have called an aggregate entity. Those are some of the key things that we have within the DDD world.
Okay, thank you.
Other questions? Okay, looks like you guys are going to make happy hour. Thank you.